boss, plant science boss. Plants.
Gets freaky with plants.
But not animals. The mitochondria is the powerhouse of the cell. His arms are big, but his brain is bigger, filled with the knowledge of eukaryotic life.
America's largest industry revolves around the world's oldest multicellular organisms, plants. Plants are our food, our clothing, and our medicine. They are everywhere. Have you ever wondered what plants are doing while you sleep?
They sleep too.
Do they use the bathroom? Nothing. They do nothing.
Plants are hard at work even when the sun is set. However, during the night, plants work differently. They have specific growth patterns. They absorb different light signals, and they change the chemical processes happening within it. But how do they know to do it?
They're smart.
Their parents tell them to.
They don't. They don't do anything.
They use special proteins called circadian clock proteins, and today we're going to talk about one in particular, the late elongation hypocotyl transcription factor.
What did he say?
Did he just sneeze?
Elongation hypo what now?
The late elongation hypocotyl transcription factor, or LHY for short, is a molecule that is directly responsible for controlling genetic information. This molecule is made up of various amino acids in a sequence that scientists generally call a protein. To be specific, LHY is what we call a circadian clock protein. That means that it's controlled by the time of day. The amount of LHY in plants peaks just before the sun rises. It is at its lowest levels while the sun is setting. So during the night, LHY levels are constantly increasing. When this protein is attached to plant genetic material, or DNA, the DNA is incapable of being understood by the plant. However, if the molecule ever falls off the DNA, then the plant can continue as planned.
LHY is directly responsible for nutrient uptake, nutrient synthesis, and many other important functions. So let's imagine a world without LHY. What would that look like?
It would look scary.
We'd all go hungry.
It wouldn't! It wouldn't look like anything!
There would be no flowers. The plant would be clueless during the day and during the night. It wouldn't know what to do. It couldn't control many aspects of its genetic material, and stresses such as cold and salt content would kill the plant in an instant. All of our plants would die. Okay, but now here's the real question, and this one's a kicker. You might even go as far as to call it an exam question. What would happen if you were to have too much LHY expressed in a plant? Anybody? Bueller? Bueller? Well, I'll tell you. Because LHY is what we call autoregulatory. It's its own boss, not me.
LHY autoregulation is controlled by the amount of LHY in the plant. The higher the LHY concentration, the more likely the protein will become detached. If we think about when the plant is making LHY, we can figure out when it will be attached to the plant's DNA. After the sun sets, LHY synthesis begins. This means that any LHY found in the plant will most likely be found on the DNA itself. While this is occurring, the DNA scanner, RNA polymerase, can no longer read the DNA. However, because the amount of LHY in the plant increases throughout the night, eventually there will be so much that it falls off. Detaching from the DNA means that the DNA can now be read, and other important plant molecules, such as abscisic acid, can now be made. Well, that's it for today, folks. Tune in again next week when I talk about Venus flytrap dental hygiene.